Last class we learned how to write the electronic configuration of multi-electron atoms. So we continue with our lecture on atomic structure, periodic table and chemical bonds. So today what we are going to learn is we learned how to use Hund's rule to write down the atomic structure, the electronic configuration of multi-electron atoms. Hund's rule, that we know what is Hund's rule. Now we are going to deal with a case which does not follow Hund's rule. So what we call it as an exception to Hund's rule. Hund's rule is not always valid, so we will deal with a case where Hund's rule is not valid. Exception to Hund's rule. Exception to Hund's rule. So what is it basically? So what is it? So exception to Hund's rule. So before that, we are going to write down the electronic configuration of argon, which has 18 electrons. And this is the electronic configuration of argon: 1s2, 2s2, 2p6. So let me change the color here. So it's 1s2, 2s2, 2p6, 3s2, 3p6. This is the electronic configuration. So if I write it pictorially, then this is the 1s orbital having 2 electrons, 1s2. This is a 2s orbital having 2 electrons, and here we have 3 2p orbitals each having 2 electrons. So 2p6, here we have the 3s orbital having 2 electrons, and then we have the 3p orbital having, so we have 3 3p orbitals each having 2 electrons, so that is 3p6, and you can see the sum total is 18. And this is a very stable configuration because argon is inert gas. Very stable. Why? Because argon is inert gas, means it hardly reacts with any chemical substances. That shows that this electronic configuration is extremely stable. Next we go to the chemical compound which is just before chromium. It's denoted by V and it has 23 electrons. So what is the electronic configuration of V? So what we have is, so V has 23 electrons, so we will just use shorthand notation here. So till here it's the electronic configuration of argon, and we have written down the electronic configuration of argon. After that it is 4s2 and then 3d3. So argon we know, and after that we have to go to Aufbau principle. And if you go to Aufbau principle, we just go to Aufbau principle, yeah. So we have 4s, and so after 3p we have 4s will be filled up, and after that 3d will be filled up. So that is what we are going to do here. Okay, so yeah. So here this is the 4s. So after argon, the 4s will be filled up, 4s2. Okay, so there will be 2 electrons, and then there will be 3d3. So there will be 3 electrons in the, so we have, here we have 5 3d orbitals. So each one will be containing an electron with spin up. So that means 3d3, and these will be vacant. This will be vacant, this will be vacant. Till this one it's fine. After V it comes chromium. So chromium has 24 electrons in the 24 electrons. So its electronic configuration will be that of argon, and then 4s2, 3d4, one more electron. If I write like this, this is wrong. Why wrong? because this is not the configuration, this is not the configuration, electronic configuration, I mean, this is not the electronic configuration with lowest energy. Okay, this is not the electronic configuration with lowest energy. That's it. Okay, so if you write it in pictorial form, then 4s2, this is 4s2, 4s orbital having 2 electrons, and then 3d4. So this is 3d4. So we have 5 orbitals, 5. So this we have 5 3d orbitals, and 1 electron goes here, 1 electron goes here, up, up, up. That's it. This is Hund's rule. What we have done is Hund's rule, but this is not correct. The correct configuration will be this one. So what happens is, 1 electron, say this electron will actually go to, so this electron will actually go and sit here, and then that will, so this will now have only 1 electron, spin up, and this one was not filled, so this electron will go there and it will sit there, and this configuration is more stable than the previous one. So we have this configuration. This configuration is not the most stable one, this is the most stable one. So this is my 4s, so 3d. So what we have learned here is that, so this is half filled, this is half filled, like half filled. There should be 2 electrons, but here this subshell has only, this orbital has only, this orbital has only 1 electron. So this is half filled, right? This is half filled. This subshell, which is part of 3D, it should maximum electrons, this is also half filled, half filled, half filled, half filled, because it contains 5 electrons. Maximum is maximum electrons, it can contain, maximum electrons it can contain is 10. So instead of 10 it is having 5, so it's half filled. So what we are saying here is, so here it's fine. So half filled subshells, so point is half filled, subshells are more stable. More stable means having less energy. More stable means less energy, and this is what we want. So half filled, so this is more stable means this is having less energy. So that's why this is preferable to this one, where this is full but this is not half filled. So half filled subshells are more stable, so that's why this is the configuration. So this is the electronic configuration for chromium, and that's why it is called an exception to Hund's rule. So we'll end today here, and in the next lecture we will do shapes of orbitals. So thank you.